So here we'll start by graphing these inequalities, and I'll start with the linear inequality. That's the easier one. And here the y-intercept, and again, just have to do it qualitatively. 1, 2, 3, because if you don't do this, it's hard to see what's happening, and x-intercept would be minus 4, 0. So it's a straight line. And then it's going to divide this into two half planes to figure out which one is shaded, or the region that satisfies this inequality. We'll use the origin as the test. You will see that that is not true, which means that the points in this half plane satisfy this inequality. Now next we come to this, and you'll immediately recognize that this is a circle. So I'm going to rewrite this by completing the squares. And I hope you're comfortable with this algebra. Just make sure you can even check my work, and that this isn't really equivalent to that piece. And next I'm going to do is to add 8 to each of these three terms, and that becomes plus y minus 2 square less than or equal to 8. So here, if you notice, if we start with this circle, the one on the right, meaning this piece, and I'm going to start with the equal part. You see the center is minus 2, 2, so that's going to be right here. In fact, that's going to fall on this line, and you can check that when x is minus 2, if you replace that, y is 2. So that's what makes this question easier. If it wasn't there, it would be a lot harder. And you'll also see that these 2 points, the y and the x-intercept, are the endpoints of the diameter of this circle, because you'll see when x is 0, if you replace that, and y is 4, that this does satisfy the equation of the circle. So the circle is going to look, sometimes my drawing is not, does it also go through the origin? Yes, it does. That part isn't that important, but this is how that circle would look like. And it's less than or equal to 8, so that shaded region is inside that circle. Then we have another circle equal to 4, this part. And here the radius is 2 units, so it's going to go through, it will be here, minus 2, 0. And so it's going to look, it's going to look something like that. And it's less than or equal to 4, which means all the points inside. So we're looking for the intersection greater than or equal to 8, sorry, less than or equal to 8. Yeah, I think I made a mistake here. It's not inside, it's going to be outside, because this part is greater than. So here it looks less than, but I need to rewrite it. So it's actually outside the circle. And so if you look at the intersection, it's going to be that little slice here, this piece here. Let me just make it all black. And so we need to figure out the area of that. And since this is a diameter here, it's just the difference in the area of these two semicircles. So half pi, that radius is going to be square root of 8, which is 2 root 2, but we're squaring it. So really it's just 8. And then minus the area or the half semicircle of this inside circle. So that's going to be 2 square. So it's that. If I take out half pi, it's 8 minus 4, or half pi times 4, which simplifies to 2 pi. So the answer is C. So yeah, I mean, it's a hard question in the sense that you have to kind of rearrange this and be able to graph the circle inequalities. And that means this skill set of being able to graph circle inequalities is important, as is straight lines. So those are the two key pieces. And then, of course, the rest is just putting it all together. So the summary, the answer is C.